Repeating patterns are those patterns that have a core that repeats. For example, red-blue could be the core, and a string of beads continue to form the pattern red-blue, red-blue, red-blue. Red-blue is an A-B type of pattern. Non-number patterns can build a foundation for later noticing numeric patterns. Physical materials provide a trial and error approach and allow patterns to be extended beyond the few spaces provided on a page. By using a variety of materials such as colored blocks, buttons, connecting cubes to create and extend their patterns, students begin to generalize ideas of patterns. An important concept in working with repeating patterns is for the students to identify the core of the pattern. There's different repeating patterns everywhere. The seasons, the days of the week, the months of the year. Also find stuff in real life, such as the school, home from school, set the table before eat, clear the table after eat. Oral patterns can be recited too. Do me, me, do me, me. Students can explore patterns that involve a progression from step to step. These are called sequence or growing patterns. With growing patterns, the focus is analyzing how the pattern is changing with each new element in the pattern. If you look at figure A, there's one triangle that requires 3 triangles, 2 requires 6 triangles, and then step 3 is 9 triangles. Step after that would be 12 triangles. The function for this would be 3 times the desired number of triangles. Analyzing growing patterns should include the developmental progression of reasoning by looking at the visuals, then reasoning about the numeric relationship, and then extending to a larger or the nth case. Students' experience with growing patterns should start with very straightforward patterns and continue with patterns that are more complicated. The description that tells a pattern changes from step to step is the recursive pattern. It is easier to see the patterns from one step to the next than seeing the increase or decrease. Covariational thinking involves noticing how two quantities vary in relation to each other and being explicit in making the connection. In a T pattern, a student might say, as the step grows by 1, the number of tiles needed grows up by 3. As the student is connecting how the changes one quantity affects the change in another quantity. The explicit relationship, also called the correspondence relationship, is a correlation between two quantities expressed as a functional rule. In the T pattern, the rule was 3x plus 1. Imagine that you needed to find the number of tiles for the 100th step in the T pattern. If you use recursive thinking, you will need to find all the prior 99 entries into the table. If you notice how the x and y correspond the explicit rule, you can use the rule to find how many tiles are needed in the 100th T. Growing patterns have been represented by the physical materials or drawings, a table, words, and symbols. A graph adds to a fifth representation, and one that effectively illustrates covariation. In the illustration below, these 5 representations look like with the connecting context of the selling of the hot dog. Independent and dependent variables. The independent variable is the input or whatever the value is being used to find another value. The dependent variable is the output. Discrete and continuous functions. When isolated or selected values are the only appropriate for the context, the function is a discrete. If all the values along a line or curve are solutions to a function, then the function is a continuation. Domain and range. The domain of a function corresponds with the possible values for the independent variable. The range is the corresponding possible values for the dependent variable. After the graphs are drawn, students can pair, compare, or select graphs that can be shown to the whole class. Let students examine the graphs to see whether they can determine the matching situation from the above list.